Welcome back to Simply Green Radio here on News Radio 1180 WHAM. Simply Green Radio brought to you by Simply Green Energy and Mr. Rooter Plumbing. A website we'd like to give out, folks, mysimplygreenenergy.com. mysimplygreenenergy.com. A phone number we can give out, 222-1180. Again, 222-1180 to join in on the conversation tonight in studio with Maurice Aubrey, Mo, Pete Morisi, True Story Pete. Filling in for Brenna Hartman tonight is Jim Salmon, our home repair expert.
I'm really enjoying this, not have to do any work. I mean, you're here doing the whole thing. It's great. I like this.
He does look pretty relaxed tonight, I got to admit. You know, I've been a guest a couple of times with Jim Salmon, and he's always real tense. And, I thought to myself, wow, this guy's really really into this. Tonight he's kicked back, and he's watching you do the whole thing. It's good.
Well, the reason I'm here is because this whole geothermal thing that has come up in the past, well, it's been around for years and years, but especially in the past 10, 15 years or so, and you're seeing systems installed every day, and it's a mystery to most people. So I came here to hear Tom talk about it and to visit with you guys to try to get a grasp on how it all works and the different types of systems, open loops, closed loops, wells, ponds, all that, and I'm looking forward to hearing about that.
It's a great segue, right?
It is. And Mo, I will leave it up to you to welcome in Tom Piekunka. Hopefully I said your name right, Tom. He is with Piekunka Systems Incorporated, and he specializes in geothermal products.
Welcome, Tom. I'll let you go ahead, and why don't you tell our listeners a little bit about yourself. We'll start with that.
Well, thanks, Mo, for having me here. I'm a professional engineer. I am a manufacturer's rep for Climate Master water source heat pumps, and I work with mechanical contractors like Simply Green Energy to lay out and help design and apply ground source heat pumps.
All right, good explanation, and we're gonna get into some things with Tom, of course, because he is our expert here tonight. 222-1180, the number to call. Again, that number 222-1180. We do have some callers though that we'd like to get to, and we'd like to get to them right away. So we'll welcome in Brian in Macedon. Brian, come ahead with your question, sir.
Hey, good evening, gentlemen. I'm glad I could listen. I'm glad I could listen to Jim again. In the evening as well. It's a double dose of loveliness, Jim. Thank you.
Gee, that's nice of you, Brian.
Yeah. Well, anyways, I had a question, guys. I have an extensive garden here in Macedon, and obviously I pay utility for water, and I already have to tell them it's okay to dig a well as long as it's not going to be potable water. And I'd like to power that well, maybe with a solar array, or possibly, if Tom would know, maybe some type of ground source heat pump. I'm not quite sure if I would need an inverter, or just keep a pump on the DC. I'd also like a handle pump, just to be able to get it out of the ground. Not that I want to totally go off the grid, but it doesn't seem like it's a bad idea. Save some money, water my gardens so they're nice and green, and I don't know what my options were there. I could mount it maybe on a shed, or possibly I have a huge trellis that's on 6x6s. It's about 24 feet long, and maybe run the pump off that. What were your thoughts, guys?
Brian, you sound like he knows his stuff here. That's some good stuff. Tom, did you want to take a crack at the first caller there, or question?
Well, the ground source heat pumps, they use electricity. They don't generate electricity, so you would need a photovoltaic system to generate that power to run a geothermal heat pump. But I actually have a ground source heat pump system under part of my garden.
A lot of farmers use windmills, too, right, to do that, like a wind tamer or SkyStream or one of those types of windmills to generate just as much as what he would need to do a pump, right?
That's exactly right, Jim.
I'm in a residential area, guys, so I don't know, quite sure if the windmill is code or, people complaining of poor birdies, all that garbage. But if that would work out, that would be great. I'm not quite sure if there are smaller models that would be fast enough or powerful enough to produce the kilowatts that I need to run that pump, and that was more of my question. Maybe just for a garden usage of water, like maybe an acre or so or a little less, what kind of, type of pump, and if the geothermal or just the solar array would be my better bet.
A solar panel, each panel gives you about 45 watts.
Oh, that's plenty.
That's about 45 watts, and you can wire them in series as well.
Oh, outstanding.
All right, and if you get a DC pump, you don't need an inverter.
There's a lot of options, absolutely.
Oh, that's good news. I appreciate the help.
There you go,
guys.
I still like the idea of putting a windmill up and see what your neighbors say.
Yeah. Absolutely. Just for kicks and giggles, right?
Exactly. See how green your neighbors are.
Don't ever let a wind guy hear you say windmill. It's wind turbine.
Wind turbine.
Turbine.
You better get that right.
Right. It's all about generators.
That's right.
All right, thank you.
Hey, Brian, thanks for the call. That frees up another line now, folks. 222-1180. Again, that number 222-1180. Brian knows his stuff. I mean, he was rattling stuff off that we've been talking about a lot here.
Yeah, and
he knows how to garden.
Yeah,
he could dig a well. He could put in a rainwater harvesting system. There's a lot of ways to go. If you got an active storm system, it's probably more cost efficient than getting into a well.
All right. I know well, we've got Tom here. I know you guys, you've got a lot of questions for him. So, Mo, do you want to throw something at Tom or?
Sure, why not? Why don't we just, hey, how does geothermal work, Tom? Let's throw that right out there.
All right.
Well, a geothermal heat pump just transfers energy. It's transferring heat from the ground into your house, or heat from your house in the summertime out to the ground. It works very much like a refrigerator. We take heat out of a 38-degree refrigerator and we reject that heat into the kitchen. So that's the way the heat pump would work in the summertime, taking heat out of your house, transferring it to the ground. And in the wintertime, it's absorbing heat from the ground, and water is circulated into the heat pump. The heat pump extracts heat out of that and transfers it to your home.
You mean it separates the temperature into hot and cold, and then it gets rid of whichever one it doesn't want? Is that what you're saying?
Yeah, there's basically three parts to a ground source heat pump system. There's the ground heat exchanger. There's the heat pump indoors, which is the refrigeration cycle. And then there's a loop system, a piping system, which has fluid in it, and it transfers the heat from the ground into the heat pump, and the heat pump will extract heat, and through the refrigeration cycle, it rejects heat into the airstream.
I think it's a nomenclature that's confusing, because we say heat pump and we expect to see a pump. But that's not what we're looking at, is it?
No, it's a compressor. It's very similar to your refrigerator, except it has a reversing valve in it, which can reverse that cycle, so it can heat in the wintertime, it can cool in the summer.
Now, is that usually like at the bottom of the system? Like if I've got a regular gas furnace, the bottom compartment, there's a flame and there's a turbine for, blowing the heat out and distributing the heat. Where that flame is that where my heat pump is now?
Yeah, the heat pump looks very similar to a furnace. It's a box that would be located, where your furnace would be, and it's ducted to your air system, your duct system, or you can have a water-to-water heat pump where that heat pump will reject water into a water source, and it can be rejected into your radiant floor system.
You mean like a well or a pond? Is that what you mean?
Well, you can use a pond.
Okay.
You can use a pond. You could submerge coils in the pond and absorb the heat from the pond.
Coils of plastic pipe.
Correct. It's a polyethylene.
And inside the pipe is a coolant.
Right. It's water with an antifreeze, typically methanol or ethanol, and sometimes propylene glycol. But
so it doesn't evaporate. It just
so it doesn't freeze because the ground temperature 6 feet below is roughly about 50 degrees, 52 degrees. But once you start extracting heat out of that soil, you can bring that ground temperature down to, you can actually freeze the ground, but you typically don't. It's usually around 40 degrees.
So you said the magic word. You said soil. Now, there's all kinds of soil. There's sandy soil. There's loams. There's rocky soil. I mean, what's the best kind of soil?
Water.
Water
is the best source.
Is that right?
If you have rock is very dense, so rock is the best conductor. And then you got you got gravel and sand, and actually sand has a lot of air voids in it. So it's not a very good conductor.
So the denser the soil, the better?
Yes, yeah.
Now, I've seen some vertical setups go in the ground, vertical drilling, and they put grout into the holes around the pipe. And what's the purpose of the grout?
It's so you have good heat transfer from the ground to the pipe, so there's good contact.
I see.
It's also there's different types of ground heat exchangers. The vertical bore, which you're referring to, that could be 2, 3, 4, 5, up to 500 feet, maybe even deeper.
Does it get any warmer down there, or is it just so we have enough pipe in the ground?
It's more constant. It doesn't fluctuate, maybe a degree every 100 feet.
Okay, so you're not gaining a heat advantage by going deep.
A little bit, a degree or two.
A degree or two.
But Usually, if you can put a horizontal loop in, it's
Right.
it's a much more economical system
I see.
than doing a vertical.
I just wanted to say for the record, I think that's the most quiet 15 minutes that I've ever heard out of you. I don't think I've heard 2 words from Salmon.
Well, I'm learning. I'm
impressed.
listening here.
I'm dumbfounded over
Right.
I might just steal Tom and bring him on the home repair clinic for a while.
I'd like to do that.
Can I ask a question?
Go real quick because we do need to take a break, but
All
go
right.
ahead, Jim.
So the typical homeowner, when they hire somebody to install a geothermal system at their house, they're going to dig a trench down 6 feet or so and put these pipe in here and take the heat out of the ground, bring it into the house, and the reverse in the summertime. So all of how much pipe you need and how much ditch you need and all of that is dependent on how big the house is and then how many, the heat loss
demand.
calculations and whatever per that house, right?
That's right. Typically for every ton of heat pump that you put in a typical 2,000 square foot house will take a 4 or 5 ton heat pump. You need a trench maybe 200-300 feet long, and you'll put 400 to 800 feet of pipe into that trench for every ton. So on a 5-ton system, you'll have 5 trenches 200-300 feet long.
Wow. Okay. Cool.
That's kind of it's a similar question that Jim, because we've talked about this before. And I'm just kind of, I'm new at this too. I'm learning this, Jim, and I'm curious to know, when you talk about drilling and putting a tank or if it is a tank. We had somebody in from this who has a building in the city, and I was just just the overall the look of things. I guess that's what I was trying to get at. Like, you might have a smaller, say, tank in the city because you only have so much space because it's cluttered. But then if you go out to the suburbs, you've got more space to do whatever you can do.
Right, Brendan.
Is that accurate?
Well, yeah, to some degree. You're referring to, I believe it was John Balone.
Yes.
From Flower City Management.
Right.
And yes, their building, actually, we can see it from this building.
Right.
And what they did is they drilled, I believe it was 72 holes,
Okay.
400 feet deep in their parking lot, which took up, a pretty decent sized area, but yet they are landlocked there, and the footprint of the field was pretty tight. But yet, the amazing part was here's a building that was built in, I think, 1920s or 1930s. Right. Yeah. They were able to retrofit it and be able to do that all within a relatively small area. And it
I guess that's what
well.
I just find so fascinating is that you can do that in such close quarters and still have it work. Whereas if you're out in the suburbs somewhere, you've got more space to deal with.
Brendan, we've been involved with heat pump systems down in the Park Avenue area where the houses are only 10, 15 feet apart.
Right.
And there's only a driveway separating the 2 houses. We've actually drilled vertical bores right down the driveway and manifolded those together and brought it into the house. So you can do it on very small lots.
That's very interesting. Very interesting.
Yeah, not everybody's got 200 or 300 feet of land to work with.
True.
5 or 6 times.
Yeah,
right.
Really.
Now, let's say I didn't have that much land. Is this where you get into the slinky loops? Because I'm getting that much pipe in a smaller ditch. Is that when slinky loops come into play?
Yeah, there's several types of ground source heat exchangers. There's the horizontal loop, which you could have a 2-pipe, a 6-pipe. You could have a slinky, which is just a pipes that are coiled together, and they are more concentrated, so they do take up less room. But there's also the vertical loops where you can drill, and you only need a 20 square foot area a 20 by 20 area to put a vertical
and that would be like a regular well driller would
yes.
drill that for you, right?
Mm-hmm, mm-hmm. Mm-hmm. Or if you have a source of water, we were talking about ponds, and I've been involved with just a spring where it's a very wet ground where you can dig out an area, submerge coils into this maybe 20 by 20 area, and that fills up with water, and as long as there's a continuous flow of water in that spring, you can take heat out of that water and heat a house.
222-1180, the number to call if you want to join in on the conversation. Again, that number 222-1180. Our guest in studio tonight, Tom Piekunka with Piekunka Systems Incorporated. He's an engineer who specializes in geothermal products, and that's the conversation that we were having tonight, all things geothermal. Of course, in studio tonight with Maurice Aubrey, also with Pete Maurice, True Story Pete, and filling in for Brenna Hartman is our home repair expert, Jim Salmon. We do need to cut away for a quick break, but we'll be back with more of Simply Green Radio, brought to you by Simply Green Energy and Mr. Reuter Plumbing, here on News Radio 1180 WHAM.